Hello, my name is Noah Hoisington,
And I am Jaden Seal.
and today we're going to teach you guys a little bit about calculus, and more specifically, the mean value theorem. So, the first thing we need to cover when learning about the mean value theorem are the conditions for which to check to make sure the theorem applies. The first is that the function is closed. You guessed it. Second, the function has to be continuous. Third, the function must be differentiable.
So this is clearly the graph of the function above, and as you can see, it clearly satisfies the mean value theorem. It is closed, it's continuous, and it's differentiable.
Okay, so one of the most important things about solving problems for the mean value theorem is finding the average rate of change across the interval. So to do that, we use this formula, f of b minus f of a all over b minus a. Now, f of b is going to be the second end of the interval plugged into the function. F of a is going to be the first end of the interval plugged into the function. So by plugging these numbers in, we get the two y values that we use for the numerator of this equation. In the denominator, we simply subtract the first part of the interval from the second part of the interval. So in doing that, we can find f of b, or f of 4, is going to be 0. And f of a, or f of negative 1, is going to be negative 5. Sorry about that. And b minus a, or 4.
So as you can see, our average rate of change on this graph is 1 through the points negative 1 and 4. And that indicates that since this follows the mean value theorem, some point, which we'll label as C, in between points A and B, the graph will have a derivative of 1. So now that we know there's a point C that has a derivative of 1, what we're going to first need to do to find that point C is take the derivative of f of x. And in this particular equation, the derivative of f of x, or f prime of x, will equal 2x minus 2. From there, since we know our average rate of change is 1, we're going to plug 1 as f prime of x. So 1 equals 2x minus 2. So now that we're here, we're going to add 2 to both sides to cancel out this 2, which leaves us with 3 equals 2x. And to get what x is, you divide by 2 on each side. So divided by 2, and we get that x equals 3 halves.
Okay, since we know that the derivative at point C is positive, that means the function at point C is decreasing. Wait. I don't know. Man, I just wish me and calculus got along.